This episode is sponsored by The Ridge. Go to ridge.com/SciShow and use the promo code SciShow to get 10% off your next order. On November 2nd, 2000, a spacecraft carrying 3 astronauts docked with the International Space Station. On board was the crew of Expedition 1, the station's first long-term inhabitants. And since that day, there have always been people on board. That's nearly 20 straight years of humans living in space. The ISS isn't just the world's coolest playground, though. It's also a state-of-the-art laboratory that's helped scientists from dozens of nations carry out thousands of experiments. A lot of that research has been focused on the human body. After all, microgravity is an environment we never evolved to live in, and we want to know how it affects us. But even if you never end up in space, your life might be changed, or even saved, by what the ISS has helped us learn over the last 20 years. First, doctors have long known that space isn't good for our immune system. Spaceflight is stressful on the body, and it can respond by becoming less aggressive toward invaders like viruses. Although NASA works hard to keep the ISS as sterile as possible, some viruses are already there when astronauts arrive, because the astronauts are carrying the viruses with them. It's not because they're actively sick, though. It's because some viruses can stick with us for years. Like if you had chickenpox as a kid, that virus has never left your body. It's just hiding out where your immune system can't find it, like in nerve cells, which your immune system doesn't check that often. And someday, if your immunity to the virus declines, it could pop up again. That actually happens to many older adults, but instead of getting chickenpox, they develop shingles, a disease marked by painful lesions on the skin and sometimes long-lasting nerve damage. But this can also happen to astronauts whose immune systems have declined in space. On the station, detecting the virus emergence early is key to preventing more serious complications. But traditional diagnosis requires specialized equipment that's way too heavy to fly to orbit. So in the mid-2000s, NASA researchers developed a chemical reaction that can detect the shingles virus in saliva just by adding a few chemicals. If a sample turns red, an astronaut knows they might be at risk and can take the necessary precautions. This kind of test is obviously helpful for the station, but it could also help millions of seniors spot this common disease before it becomes serious. Another challenge in space is that most astronauts don't have the training to perform complex medical procedures, like diagnose broken bones. But as missions become longer, it's critical that many ailments can be diagnosed and even treated on board, because it's a bumpy ride back to Earth. One useful tool for diagnosis is the ultrasound. An ultrasound machine works by sending sound waves into the body and then mapping how they bounce back to form an image. And they can be used to identify a range of conditions, from broken bones to objects in someone's eye to pregnancy. Although that last one probably won't come up in space. The trouble is, most astronauts have only basic medical training, and learning to do an ultrasound right can take hundreds of hours. So in the mid-2000s, NASA researchers developed a system of cue cards to guide them through every step of the process. Their studies showed that after as little as 2 or 3 hours of training, and with a remote expert to guide them, someone who's never performed an ultrasound can, for example, identify broken bones with 90% accuracy. Thankfully, no one's had to use those cue cards in a real emergency yet, but an astronaut has used an onboard ultrasound to monitor a blood clot. And this system has made an impact on the ground, too. After more than 100 hours of testing on board the space station, NASA tried the system with a Detroit hospital, plus the city's professional hockey and baseball teams. In the test, the team's athletic trainers used portable ultrasounds to quickly diagnose players' injuries, allowing them to get care faster. And since then, this technique has also been tested with U.S. Olympic teams. In the future, this system could be deployed widely to facilities in rural or remote areas who often lack the access to rapid, high-quality diagnosis. Finally, sometimes even research unrelated to health can have surprising medical benefits. Spacewalks, for instance, are dangerous and hard, so astronauts use robotic systems as much as they can. The latest tool is Dexter, built in Canada and installed on the station in 2008. Each of its arms contains 7 joints, allowing it to make moves impossible for humans with millimeter-level accuracy. And because Dexter can be controlled from the ground, mission controllers can perform inspections and maintenance while the astronauts are busy with other tasks. But turns out, these robotic arms had a few other tricks up their metaphorical sleeves. Around the same time, engineers took the technology that powers Dexter, plus a couple of other robotic space arms, and used it to create NeuroArm, a revolutionary surgical robot. NeuroArm lets doctors perform brain surgery in a place no surgeon could work, inside an MRI machine. MRIs allow doctors and techs to monitor what's going on in someone's body. But using them during surgery normally means pausing an operation to take images. But NeuroArm is designed to work alongside MRI machines, so it allows for real-time monitoring of a patient's brain while it performs extremely complicated surgeries. And today, the precision technology behind Dexter and NeuroArm is also being applied to help with some of the most challenging surgeries, procedures involving babies and small children. So while it's amazing that we can soon celebrate 20 years of continuous human habitation in space, that's ultimately not the real story. More important is what those 20 years have enabled. New treatments, better diagnosis, and almost magical technology. Just think of what we might be able to do in the next 20 years. Thanks for watching this episode of SciShow Space, which this week is sponsored by The Ridge. Among other things, The Ridge makes wallets, specifically fancy, sleek wallets. They're designed to hold everything you need, but also be thin enough so they're not bulky or heavy. A lot like the supplies on the ISS, actually. If you're interested and want to check them out, The Ridge team will give you 45 days to test drive one of these things. And if you don't love it, you can send it back for a full refund. To learn more and to get 10% off with free worldwide shipping, you can go to ridge.com/SciShow and use the code SciShow. The link's in the description.